Hi, I'm Timon Sloane with the ONF, and today it's my pleasure to welcome Pranav Mehta from Intel to join us to discuss Intel's activities in 5G, mobile, and at the edge. Pranav is a VP at Intel and Director of Intel Labs System Software Research. Intel has been a terrific partner with ONF, and it's my pleasure to welcome Pranav today. Pranav, take it away.
Hello, and good day to all of you, wherever you are on the planet these days. I really appreciate this opportunity to talk about the infrastructure challenges that we as an industry face as we try to bring the promise of 5G to fruition. We at Intel, and especially within Intel Labs, have been working with the ONF community for many years to create an open platform that will really foster a vibrant developer ecosystem and accelerate the pace of innovation to really bring many of these ideas to reality in an accelerated fashion. Now, when you hear people talk about what they are doing around 5G, you will notice that there are invariable references to the notion of edge infrastructure as they are talking about 5G. And I would submit that if you really look at 5G technology, outside of the traditional generational improvements in the air interface, in terms of spectral efficiency, bandwidth improvements, etc., most of the ambitious goals of 5G really coincide with those of the edge computing. And if you look at the multiple use cases, whether it is from immersive entertainment to autonomous systems or healthcare or manufacturing, public transportation, you name it, all of them, and especially what it would be required to bring those use cases to reality. Essentially, the problems that you face, the challenges you face in terms of 5G are the same challenges that you would face in terms of the edge computing. So in my mind, 5G and edge are essentially equivalent when you talk about some of these infrastructure challenges. And when we talk about the edge, again, depending on who you are talking to, whether you are talking to the enterprises in terms of manufacturing or governmental agencies, healthcare institutions, etc., or you are talking to the telecommunications operators, there are two types of edges. What you see here on the screen, a little bit to the left of the center, is what we would call the on-premise edge or on-prem edge. And what you see towards the right is the network edge or the telco edge. Both of them have the same drivers in terms of what they are looking for: better latencies, higher bandwidth, better security, and reliability of connections in terms of redundancies, etc., so that you can enable some of the use cases that people are looking for that I mentioned earlier. So let's look at what we are going to do in ONF around this network edge. About creating an open platform all the way from the core network to the access networks, and I will come to that in a moment. However, before going to that, I would also like to take a moment to talk about how we are going to create the use cases or the end user applications that will exercise this underlying open infrastructure so that we can actually improve that and make sure that we are making the right trade-offs. So first and foremost, we can debate whether we were dragged into this new normal or we were welcomed into it. But the fact is, we all are living this new normal in terms of how we work, how our children learn, how we entertain ourselves, how we socialize, or even get some medical checkups. But as more and more people have used some of these tools to do these kind of remote activities, people always talk about, and I know that we are using Zoom as a tool today, but people talk about the Zoom fatigue. And that sense of discomfort after multiple uses of these tools comes from the lack of realism. In real life, when we are in front of people, you move your head and the contents in front of you ever so slightly shift. When we are talking to people on Zoom, that sense of realism is not there. And it creates discomfort, it creates distrust, because the visual clues that we get are the faulty ones. And sometimes lack of visual clues is better than the faulty clues. So we want to solve this problem by having multiple cameras capture the light field at the source and then move it through the edge and the cloud infrastructure so that you can manipulate the visual field, and then on the at the destination, depending on how the user is moving his or her head, you kind of manipulate the video streams so that you are rendering the right perspective for them. So this is the work that we are working on within the labs so that we can enable 6 degrees of freedom to create that more realistic view. However, as we try to do this, you realize that at the camera peripheral of the host PC, you have to do a lot of dynamic calibrations between all these cameras. You have to encode these video streams, move them into the cloud, and in the cloud, you are not only doing decoding of all these video streams from multiple cameras, but you are really doing disparity calculations. You are creating optical flow, trying to figure out how to encode the streams for the target device. And then, of course, on the target device, you have to do view manipulations to make sure that you are rendering the right view to the user. And as we try to bring more realism and increase the number of cameras, as you can see, the kind of compute capability that is required increases significantly. Another example that I would like to mention is the online gaming piece. Here, if you can see today, client-based gaming, you really have to balance your latency, quality, and throughput metrics so that you stay within whatever the compute power you have within your client device. However, we see a trend going to the cloud gaming so that you can use the computation, a much higher computation bandwidth in the cloud to improve the compute throughput required and quality. However, what we have also seen is that there is a tremendous latency factor introduced with this kind of end-to-end gaming paradigm between the clients and the cloud. And what you see here are some of the factors that contribute to this increased latency. In fact, we have done this on one of the public clouds, and what we see are latencies almost in the 170 millisecond kind of range. And even though the quality of the frame is better, there is a lot more jitter, which really decreases the experience of the gamers. So what we are proposing is a new paradigm of client, edge, and cloud-based gaming so that you can really address some of these latency aspects with this new paradigm. And what you see is we would like to reduce the end-to-end latency close to the client scenario. And then, of course, we would like to improve the quality. The example I showed with 170 milliseconds on the left side was still with 1080p kind of content. We would like to take it to 4K or even higher without having any of the artifacts. And of course, we would like to have improved and consistent throughput at 60 or higher frames per second. So these are the kind of use cases we are developing so that we can exercise the underlying infrastructure as we develop that, working with the ONF community, so that we'll have a good way to test out these things and improve them at a rapid pace. So most of you are probably aware of ONF's Open Mobile Evolved Core, or OMEC, which was the first step towards this open platforms. What we did over the last few years is that not only we created this open platforms, but we also made it cloud native. So we kind of cloudify it, and that was the first step. And then we are working now towards the 5G based infrastructure, where we are taking those user plane functions, the data path essentially, and kind of trying to disaggregate it so that you can move them closer into the operator's distributed clouds. And now the focus over the last year or so has been, how do we then combine these UPFs with the distributed units that traditionally sat in the radio access network, the central units that can now go into the public cloud, and really eventually get to a point where you can have these functions anywhere in a hybrid cloud scenario, but they are all secured through our SGX technology, so that there is no, even though things are running in public clouds or private clouds, they are secure wherever they are moved. So that is the kind of eventual goal that we have. You may have heard the term COMAC, the Converged Multi-Access Core, that ONF is working towards. And we are very much working with the community to bring that to reality. Now, when we talk about a user plane function, user plane forwarding function that needs to scale from the core all the way to the edge, we need to make sure that it is designed with significant flexibility. Because when you are running closer to the edge, most likely you are working within much tighter cost and power envelopes. And this is where it may make sense to use the general purpose compute that is available in the edge, because then you can use that general purpose computation for other functions as well, depending on the bandwidth required. So that is where we are using the DPDK-based software fast path options, leveraging a lot of the technologies that we have built into our platforms over the years for quality of service, as well as significant tens of gigabits of throughput in those kind of functions. And of course, it comes with all the security functions as well. But as we move closer to the core, the throughput requirements go high, the latency and jitter requirements get tighter. And that's where a Tofino switch-based fast path may make more sense running with the P4 runtime. And that is what we would have available as well, providing a seamless path to the session management functions that are running in the cloud from a control plane standpoint. So this is something that is going to be one of our key contributions as part of the COMAC. The other area that we are also contributing to is the radio access network piece. You may have just seen the announcement around software-defined RAN coming out of ONF. Intel Labs is bringing some of the value-added services to the near real-time RAN intelligent controller form of connection management as well as traffic management, where depending on your traffic load, the radio conditions, you essentially select the right kind of band or right kind of cell for a UE to connect to. So that is the connection management piece. And then the other piece is about how we route the packets from a traffic management perspective to the UE, depending on those conditions, so that you have the best packet forwarding path for meeting your throughput and quality of service requirements. And here we are going to be delivering some of these building blocks, initially most likely in a proprietary fashion, but really supporting all the open interfaces that Open RAN has defined. But the goal would be always to get to an open source implementation eventually. As part of this, we are also working with Open RAN community to extend the E2 and A1 interfaces so that we can actually bring some of these capabilities. And we are also going to be adding to the AI framework to really improve the performance of the near real-time RIC as well. I talked about the traffic management piece, and one of the key technologies that will enable this packet routing to the UEs in a seamless fashion is what we call the generic multi-access or GMA technology that we are pushing through IETF. It's a trailer-based encapsulation protocol that really slides under the IP layer, and it allows you to make seamless transition from Wi-Fi to 5G to even DSL kind of technologies, so that you are providing the best handover to the UEs in terms of if one signal gets weak, you can move easily to the other kind of technology. And then you also can leverage having multiple of these access technologies available so that you can have downlink boost of your throughput so that you can actually improve the performance of your overall application. So as you can see on the right-hand side, the GMA technology, some of the simulations that we have run, it really improves the throughput significantly from the Wi-Fi only case if you combine both the Wi-Fi and cellular technologies. And at the same time, it significantly reduces the latency when you have GMA using that redundancy. And of course, all these pieces are going to come together in deployment for what we call the AETHER. We have this goal that we will be running these UPF as well as some of these services that I talked about in these AETHER nodes that we now have spanning the entire globe with multiple carriers as well as some of the enterprises running these AETHER nodes. In them, we have one at Intel, and ONF is really acting as the operator for these AETHER nodes so that we can bring any of the fixes that happen to all of these deployments quickly, and we can make sure that all of us are having this access to these open platform where we can innovate much faster. So we are really looking forward to working with ONF on that. However, I will also say that our work doesn't end just at this. We also recognize that as we are trying to enable some of these video-centric capabilities, we have to look at other parts of the infrastructure. And one of such cases happens to be the storage subsystem. We have developed what we call the Visual Data Management System, or VDMS, so that as you are getting all these video feeds, we extract the appropriate features from these video streams and store them into a metadata database that is using our persistent memory technology so that you can access. And if you have a visual query, you are looking for certain specific things, you can get to those specific frames much faster than what you would have been able to do. I have one example showing here where you can see that there is, in this clip, you have multiple different things going on. Two people essentially riding a horse, riding bicycles, etc. But if you are looking for only those frames where there are people on horses, you can quickly curate your pipeline through VDMS so that you can get to those frames much quicker than what you would have been able to do otherwise. In many of these examples, what we see is an average improvement of almost 15x. So again, these kind of innovations in storage subsystem, along with some of the network infrastructure piece that we talked about, we need to combine all these pieces so that we can enable the use cases that I talked about earlier in a meaningful fashion. And of course, these are all going to be open source libraries available on our platforms. So the goal really is to create an open end-to-end testbed that has all these standard high-volume server-based platforms. You bring all these network functions on top of it, and then you layer all this open source ecosystem on top of it. ONF, we also have openness, OpenVINO, Open Visual Cloud. And the goal is, as I said, again, to create that vibrant developer ecosystem so that we bring everybody together to bring their innovations to this, because 5G paradigm demands a new edge infrastructure that is going to require different things rather than just extending the cloud. And many of the visual cloud workloads will offer, we believe, unique insights so that we can make some of these system partitioning trade-offs much better. And I invite everybody to participate and help in this open endeavor, because not one single company can pull this off. And as we have seen in our ONF experience, when we all work together towards an open platform, we can do wonders. So I'll stop at that and take any questions. Thank you.
All right, Pranav, thank you. That was really terrific. I really appreciate you sharing your perspective. And you know, it's remarkable and striking just the broad spectrum of Intel's work and overlap with ONF. I mean, you mentioned starting with the core and then working in the UPF, working at the edge now, working in the RAN, and then AETHER that's bringing it all together and really that exciting platform. And then Intel's up and running with us. I think you were the first external site for AETHER when we were starting to deploy AETHER and spread it out. So, you know, well, first of all, thank you. And it's just been an incredible journey with Intel. You've been kind of with ONF from the very beginning. But I guess I'm curious about that experience with ONF, and because Intel's doing a lot, but you work with us to collaborate with the operators, other vendors, the ecosystem. You know, tell me a little bit more about that experience for Intel and how best to sort of activate that ecosystem to get the power of a coalition.
Yeah, and Timon, as you know, Intel, through our last several decades in the PC industry, in the server industry, as well as now as we get into the network infrastructure space, we have always believed in open platforms, because our fundamental DNA says that no one company can solve all the problems. It works wonderfully if we all are working together to solve really big problems. And these are, as anybody can appreciate, these are going to be big challenges, because if you talk about autonomous systems versus if you talk about healthcare versus smart cities, these problems are at a scale where not one company or even industry can really solve some of these problems. We need to bring people from different domains together. And one thing I have always uh, been amazed by is that sometimes when people are in different domains, they just treat that other thing as a black box. And we as human beings don't like black box. We don't trust black boxes. We don't um, deal with those things with an open mind. So when you create these open platforms and people, we have seen this working with many of the telecommunications operators over the years. When we brought some of our DPDK, open source data plane improvement libraries to them, they started looking at it and say, oh, this is how you take advantage of all the platform features. Actually, I know exactly how I want to use, how data plane works in my particular use case, and I would like to tweak it in this fashion, and I can do 5x improvement. And we have seen that. Same thing with cloud service providers. When we gave them DPDK, they were just excited because they now knew how the whole stack worked, and they can bring their own domain knowledge and improve the performance significantly. I think that is where opening up those black boxes, allowing people that insight, it really unleashes the innovation in multiple domains. So we believe in that. And of course, I always say that open source is a double-edged sword. On one hand, you are inviting a lot more people, but at the same time, you have to stay competitive to make sure that you are able to stay ahead of everybody. But that is our DNA. And that's why we work so well with communities like ONF, because you believe in that, we believe in that, and we have seen over the years our teams work wonderfully well together, because our goals are very similar.
I couldn't agree more. Yeah. Well, thank you, Pranav, so much today. I really appreciate you joining us. And thank you.
Sure.
I appreciate you sharing your perspective, Intel's perspective, and thank you for the work you're doing with the community.
Same here. Let's go make this 5G vision come to fruition.
Sounds good. Thanks.
Thanks, Timon.